Hello, Ahmed. Can you hear me?
Hello, Joseph. How are you?
Hello, can you hear me, Ahmed?
Yes, I can hear you. Can you hear me?
Yes, I can hear you well. Yes, thank you. Hello, how are you?
I'm good. How are you? Hello, Aaron. So I have got Joseph and Aaron today in our session. How's everything going today? All good?
Yeah, all good, all good. Yeah, busy day at work now. Just getting through this report.
Yeah. Nearly finished or still have a lot to do?
A little bit to do. Just working through some of the different calculations. I think it's the main thing.
Okay, good luck. So do
Thank
you
you.
have any question for today?
Yes. So for me, Ahmed, if I'm allowed to, or if we can go through, it's just more regarding the calculating the design loads. So obviously, it's just working out the dead and live loads for the B1 and B2 beams. Just sort of wondering, probably what the best place to sort of look through for where those calculations are.
Okay. So have you gone through the examples in week 8 and week 9 or not yet?
Yeah, and obviously I've done the straining action quiz as well.
Yeah, so I can can you give me a second to open the materials for beam?
Yep.
So to calculate the loads on B1,
Mm-hmm.
you can follow the example in week 8, 8.2, the beam example. I will share the screen to show you now.
Yes, please. Thank you.
No worries.
And just whilst you're doing that, Ahmed, so with the win loads and the design loads, I'm guessing we don't have to explain like part of our 300 and 400 words respectively. I'm guessing we don't have to explain.
Yeah, sorry, it is not required to explain because this part is like a calculation part. So it's mainly word like the wording is used for the calculation. So if it is required to calculate the calculation like wind load or load life load or whatever the load is, so you have to show the calculation. You don't have to because there is nothing to explain. Like you don't have to define what is life load, what is wind load, what is dead load. It is not required. It is only required to calculate. So if you go with the requirement one by one and like answer the requirement or answer the question, so that's it. So if it is required a discussion, so you can write a discussion or essay about. If it is only calculation or like using formulas or something like this, so you have to just calculate and write down the answers.
Okay, fair
Does
enough.
this make sense? Does this make
Yeah,
sense?
yeah, it
Yeah.
does. It does. And then I guess where you explain, you say point four, where it says critical load combinations. I'm guessing that's where we're going to look for some references to explain what's actually happening.
Yeah, something like this. This is yeah. Something like this you need to explain or discuss. But other than this, so it is like calculations, mainly calculations.
Okay. No, I understand. That makes sense. Thank you.
No worries. So now I'm sharing the solved example of beam.
Okay. And sorry, just to interrupt you. So just so I follow where you're at, this isn't week 8.2. I'm guessing this is beam design part two solved example. Is that
Yeah,
right?
this is one of the important examples we have
Mm-hmm.
to help you to solve like the requirement of assessment 2 part C.
Mm-hmm.
So here, this is an example of
Yep.
B3. If you look
Yep.
at B3, the blue one here, it
Yep.
is similar to B1 you have in your shed.
Yep.
Just as like two slopes, but your one is only one slope. But the same procedure for calculation is similar. So this is intermediate rafter. This means that it carry half of the bay from top and half from bottom. So how much it carries or the load width of this beam is If you can mention 7 or less.
Are you asking that question, are you?
Yeah, I'm just
Yeah.
because from here, this is the important thing when calculating the load on beam or column. What is the load width is carried by this beam. So the load width of B3 is half the bay from top, half the bay from bottom.
Hmm.
So it is almost 1 bay or
Yeah.
exactly 1 bay, which is how much? 7 meter.
Would it be 7 if we've only got half, like if we only got one slope, or just 14? I think maybe 7.
Yeah, 7 for all of them 7 because it is. Can you see the mouse? The mouse
Yes.
pointer.
Yep. Yep.
So this beam is carrying half of this bay and half of the bottom bay. So it can carry 1 bay at a whole bay, which is 7 meter. Because each
Right.
beam carry half from top, half from bottom, half from top, half from bottom. So we are sharing the area between the supporting beam. That's why the load width of this beam is 7 meter.
Right, because it's only one bay, and we're
Yeah,
only working out 2 bays,
yeah,
right?
yeah.
Yep. Yep.
Okay,
Okay,
so this is
understand.
important thing. So now, if the second step or the first step is to what is the loads on B1. So you have because this is a roof beam, so it is ceiling, insulation, surface weight, self weight of Berlin, roof sheeting, and on weight of rafter. So in your calculation of dead weight of B1, you have to include all of this.
Right, and because obviously dead load is a load that's permanent, right? So all of
Yes,
those things would permanently be staying on top of the column slash beam.
yes,
And I'm guessing that's why we got to then work out the weight of our roof sheeting, the insulation, all that type of stuff, right?
yes.
Okay, makes sense.
The second load you need to calculate, which is easier or simpler than the dead load, which is life load. To get the life load, you have to go to the Australian standard 1170.1 and
What was that? Sorry, I missed that last little bit. Sorry.
1170.1
Ah, yep,
AS.
sure.
Yeah, so you can get the life load from there.
Mm-hmm.
In the example, you will find this, but I'm just like this is like brief what you are looking at when you calculating the load on a beam. So
Yep.
the third step in loading is the wind load, suction and the pressure on the roof and also on the walls if you are calculating for a column, because in your assessment you have to calculate the wind load on column as well. Okay,
The wind load and
so
what? Sorry, I just again I
on the
missed it.
column, the wind load on the columns as well.
Okay.
Because this example focus only on the beam, but in your assessment you need to calculate also for column. That's why I'm referring to column now here.
Okay. Yep.
Okay.
Yep.
Okay, so this is the first step. This is just like definition of loads or what is the loads are. And here how to calculate the roof ceiling, the ceiling. So from this table, you have Portland cement plaster, 13 millimeter thick.
Mm-hmm.
The load is 0.92. So you can follow same assumption from here,
Mm-hmm.
but you have to refer to that, maybe showing the table like here, or you can use other types like fibrous plaster, whatever the used one is. So you have to refer to.
And I'm guessing that table that you're on now, is that up to us to make a decision to what material we use?
Yes, because you have here under ceiling, you have in this table 1, 2, 3, 4, 5, or under the fifth one we have also 3. So you have like seven types to select. So you can just assume I assumed for ceiling line plaster 13 millimeter thick. So what is the load is 0.24
Yeah.
kilonewton per meter square. So this is what you have to indicate in your assignment.
Okay. So that's obviously up to our discretion. So when you say then times that by the spacing, what are our centers for our ceiling? Like is that up to us? Would that be like 300 centers, 450 centers? Like
You don't have to go to the detail. What you are calculating for this question, you are calculating the load on B1, right?
mm,
So you don't. What is the meaning of assuming the spacing for ceiling? You don't need it. What you have to do is multiply this load, which is, let's say, 0.29
Yeah.
times the load width here. So this what will transfer from the ceiling to the beam.
Okay, so then that would be 0.29, for example, us using that material that you
Yeah,
mentioned.
times 7. So
Times 7, right?
yes, so you get the load on the beam.
And that's for the live load, right?
No, that dead load.
Dead
Here,
load, okay.
ceiling under dead load. Again, ceiling under dead load. Ceiling,
Ah,
insulation, surface weight, self weight of Berlin, roof sheeting, on weight, all of these are under dead load.
okay. And are all those things that you just mentioned, Ahmed, are they all found in table 1170?
Not all, but like because the standard cannot give all the material, but for ceiling you get it from there. For installation you can get it from there. Surface weight is like fixed number, which is 0.1 kilogram per meter. Self weight of Berlin from the capacity table. Roof sheeting from also the brochure of the manufacturer. On weight of rafter also from the capacity tables. So
And what
not all
are
of them from the standard, but you can get them from tables or like design capacity tables, which all everything you need will be found in this example. So if you can go step by step, what you have to do is just repeat the procedure here in your assignment.
right? So pretty much everything that's in that table, right? As we go down this example that we can all obviously see, it's pretty much whatever whatever the force unit area is times the spacing, which would always be the same. And then ultimately, I'm guessing we're going to add all of those together.
Yes. The main thing you
And
need to consider or you need to keep in mind, the load on beam is kilonewton per meter.
so yeah, so it's
If
it's
yeah,
kilonewton per meter square
no,
times.
kilonewton per meter. This is the final load we need to get on beam. So anything you will assume or you will get from table kilonewton per square meter, you need to multiply it by the load width
Yeah, so you got to go kilonewton per meter square
times
times
meter. So
meter,
it
which
will
gives you,
be kilonewton per meter.
and that's your final answer, right? So you get all your,
Yes.
and
Yeah, because
we got to list all those components and then add them together, and that will get us.
yeah.
Yeah.
Otherwise, because the unit is very important in this assignment, and there is a lot of weight on the units and the calculation. Because if you cannot get the units correctly, so this means that all the answer will be wrong. That's why the units is very important. Because you cannot like sum kilonewton times plus kilogram. If they are different units, you can't sum them together.
Yeah.
Okay, so this is for ceiling. So as I mentioned, the weight of ceiling on beam will be 0.29 times 7. What is 7? 7 is the load width.
Yes, but that's the space in between the.
The two beams, the beams.
Yes. Yeah. And obviously,
Okay?
the unit weight is whatever this unit weight is. It's 0.29. Whatever the example was.
Yes.
Yeah. Okay.
The next step is the unit weight of the insulation. So as I mentioned, you can find this also in the 1170.1
Mm-hmm.
table A1.
Yep.
So again, you can select whatever the type which is suitable to a domestic shed,
Mm-hmm.
because as you know, this is like general table, so it can be used for any other other use, not only the sheds, but you can select one of these.
Mm-hmm.
So I suggest to use like light one, not very heavy one, because it's already this roof is not accessible, so you can use a light one, like maybe fiber cement sheet, uncompressed or compressed, or even whatever the type you will use, just mention it in your assumption, in your assessment.
Yep. No, makes sense.
Okay, so for this example, the example choose insulating sheet, which is fiber cement sheet, insulating sheet, which the weight, what is the weight of this? 6.9.
Mm-hmm.
but this for cubic meter. So the unit is kilonewton per cubic meter. So if we go here, so here we have to include the thickness and the spacing because it is not ready for use, not like the ceiling. Because you see
Right.
here, because the
Yeah.
unit here is kilonewton per cubic meter. That's why a further step is needed for this one. Okay?
Right. So because it's by volume, you
Yeah,
then got to work out the thickness of your insulation, which you'd get in your product brochure,
yeah,
plus the spacing, which is still, and then because that's 3, that gets you back to kilonewtons per meter, right?
yes. Because at the end we need to like reach the kilonewton per meter, which is our final answer unit. So because it is kilonewton per cubic meter, we need to multiply by thickness. When we multiply by thickness, it becomes kilonewton per square meter. And then we will multiply by the load width. We can change it to make it load width here.
Yeah.
Okay, so if you can replace, because just to match with other things we have done.
Yeah.
Can you still see my screen?
Yes. Yep. Yep.
Yeah. So I will just replacing with load width. Right. I can't. Okay, can you get my point here?
Here we go. Yeah, you're going to start writing now, so we can see. Well, I can see what you're doing. I'm guessing probably everyone else can, maybe.
Okay, just need
Yeah,
to.
I can.
Okay. Okay, so how much this one is? This is 7 meter, as you can see. So still the load width of our beam. Okay. So now we find the load on the beam from insulation, which is 0.483. Okay. Are you still with me?
Yep.
Yeah. Okay. Anyway, what is the next step is fixed surfaces. So the fixed surfaces is taken as 0.1 kilonewton per square meter.
And is that square meter of just that is that just the square meters of your like that area that beam's going to have to service, or is that the square meter of your whole roof?
Yeah, any square meter means 1 by 1 meter. So it is for the whole roof, not only for the area for the beam, because this is a general distribution of the load on the whole area.
And we have to factor in the pitch factor of our roof.
Just I want to ask if you understand this. So what we need to do to convert it to kilonewton per meter? We need to multiply by something. What is this something? Is this parameter?
Is that the 9.81 meters per second squared?
No,
No, that's the kilogram one. Sorry.
Yeah. Here, what we have to do to convert from kilonewton meter to kilonewton, sorry, for this one here, for the ceiling. How we convert from kilonewton meter square to kilonewton meter? We multiply by the load width. Okay, so again, anything in kilonewton per square meter for beams, we need to multiply by the load width. Okay. So if we go back here to convert this to kilonewton per meter, we will need to multiply it by the load which is 7 meter. Okay.
We have to do this. So mine says do not allow for services.
Yeah, this is what I was intending to say. For the assignment details, if you go to the assignment details, you can neglect the surfaces. So for this one, I suggest you just not include it in your assignment, okay? Because this was for old version of the course, and now we can neglect it, okay? But if you use it, it doesn't affect the answer much. But yeah, if it is clear in the assignment details, so please ignore it, okay?
Yeah, I don't think my word count will allow it, to be honest.
Okay, you don't have to, because if it is mentioned in the assignment neglect, so you have to neglect it. But it's just because you are following the example, so you can neglect it in your assignment, okay? What is the next step is? The next step is the weight of Berlin. So as you know, we need to consider the number of Berlins used and then calculate the load for these Berlins. So what we have to do is just some definition of the Berlin. So what you have to do is to select or assume a Berlin size if it is not given in the assignment details. Is it given to you in the assignment details to use a specific Berlin?
No, it's not given.
Okay, so what you can do, just to simplify the work for you, is to follow what have been done here. So here, what is the size of the Berlin selected, Z or C? 200 to 24. So you can use similar Berlin. Okay. What is the on weight of this Berlin here? What you can see here. Here is the on weight in kilogram per meter. Okay. So this is the weight of the Berlin. But to calculate the weight of the Berlin here, as you can see, the weight of Berlin in kilogram per meter. To calculate the weight of Berlin on B1, you need to follow same steps here. What you have to do is to calculate how many Berlin, or what is the number of Berlin used in our shed. Have you done this?
Yep, I've done that. I'm gone past that bit already.
Okay, so what you have to do is we have to assume a number of Berlin similar to this, but here, because this frame has like two inclination or two slopes, so we are looking for 1/2 of it. But for your shed, or the shed in the assignment, you have to consider the whole length, like here. So the whole length, and whatever the whole length is, let's say it is 8 meter in your assignment. So you will assume similar to this, maybe. We have 3 internal spacing and 2 external spacing. For the external spacing, it is taken as 0.75x because the wind speed or the wind pressure in these areas are bigger or larger than the wind pressure in the middle area. So you will have 2 times 0.75x plus 3 times x. So the total number of Berlin spacing are 4.5x. So x, or the internal spacing, is the span of the beam divided by 4.5, and you get the Berlin spacing as 1.78. So the external spacing will be 0.75 times the value we got as 1.75, which is 1.33 meter. Okay, is that clear?
Yeah, I've done that, and I changed it to make sure that the X was in the range of 1.25 to 2 meters. But I'm assuming that's okay for span rib, like I've been told to use like Lysart span rib for the roof sheeting. But I couldn't find where the purlin spacing maximum and minimum for span rib was, so I just went between that 1.25 to 2 meters, if that makes sense.
Yeah,
Is
this
that
is
okay?
like, yeah, this is okay, because this is like not a formula or something, but this is by experience. So they allow for from a range of 1 to 2 meter. So this will be a good range of purlins.
Yeah, okay, no, that's what I did, but I did go digging down span ribs documents to try to find what they wanted, but I couldn't find that, so I just stuck to what this said here.
Yeah, if you want to go for this detail, it will be the width of the sheet from for the manufacturer send to the sites. So the product has each roof sheet has a width of the sheet itself.
Oh,
Because-
okay. Yeah, no worries.
So this will be the maximum spacing for the Berlin.
Yeah,
Okay,
no, that makes sense. Yeah.
Okay, no worries. So now, how to calculate or get the load of Berlin on the beam? So what you need to do is follow this formula here, which is the unit weight of Berlin. The unit weight of Berlin, we get it from the table of Lysat, if you use Lysat Berlins, times the load width of the beam, which was 7 meter in our case here, number of Berlin divided by length of rafter. Okay, so from table, we get it as 7.24 kilogram per meter. Here is the problem. What is the problem here? As you mentioned earlier, Erin, so we need to convert
It's the
this
unit.
kilogram, the unit. So 7.24 times 9.81 divided by 1000 to convert it from kilogram to kilonewton. And then times the spacing, which is 7 meter, times number of Berlin. How many Berlins we have here? If you look at this figure, we have 1, 2, 3, 4 in the middle and 2 on the edge. So the total number of Berlin are 6, and the span of the beam is 8. Okay, so the answer, which is finally in kilonewton meter after conversion, is 0.372. Okay, do you have any question about this? No?
No, does make sense. Thank you.
No worries. And also, I want to advise you to be mindful with the numbers or with the results, because you are like doing almost similar spans and similar loads. So the final loads or the final answer should be also close to what you have seen in this example. Okay, so if you find the number are very far from here, like 0.0003, something like this, or 10,000 kilo, so this means that you have done something wrong in the calculation.
Should we keep it in like how many? Should we round them to 2 decimal points or anything, or it doesn't really say what we should do for it?
Because this is like not AI marker, so whatever you did will be acceptable. But I mean, because when you round up too much, this will affect the final result too much as well. But if you keep it like at least 2 decimal or 3 decimal places, it will be better.
Yeah, no worries at all. Thank you.
No worries.
Now, Ahmed, that makes sense. So I'm guessing what you've just explained would be relevant also for the dead load on B2.
Did load in week 2?
So this is for the dead
beam
load.
2?
Yeah.
No. I will explain also the dead load for beam 2 because also there's a confusion. There is some confusion at this point as well. But can you tell me what is the difference between beam 1 and beam 2?
So dead load on beam B1 is for the rafter, and then dead load on beam B2, there's no rafter.
No, not like that. I will explain. If you look at your shed, what is the difference between location of B1 and B2? B1 is a roof beam. B2 is a floor beam. This is the main difference between B1 and B2 in the assignment.
Yeah, so we have to calculate as general storage area as well.
Yeah, because B1 will be considered similar to this example here. That's why I start with this example. This example is a roof beam. But you cannot do the same for B2 because B2 is a floor beam. So as you said, Erin, it should be like storage area or something like that.
So when you say floor beam, is that what you said?
Yes.
Is that then meaning that would be between like your ceiling and your roof?
Yeah, it is the mezzanine floor. Mezzanine floor.
Right. So it's like whatever would be above your ceiling, whatever you would store above your ceiling, in between your ceiling and roof, right?
Yes. But
Yeah.
if we can keep it for the next example, so it will be better because I don't want to confuse you with the two example at once.
Right.
Okay, so all these steps will be repeated in beam 1. So when you calculate beam 1 in your assignment, you have to repeat all of that.
Yeah.
Okay.
And that gives us that dead load, and then we can move on to our live load, obviously.
Yes.
Hmm.
So now for roof sheeting, the next component of the load is the roof sheeting. What you have to do, I think it is given to you to select one because it is already span rep as you mentioned, right? So you have to follow the requirement of the assignment. So if it is span rep, you have to use span rep. Otherwise, you can select whatever the sheet you want. Okay. Like for example, this example, what is the type selected here? Select the custom blue ORB. So what you need from here is weight or the mass. How much is the mass of this type of roof sheeting? 6.1 kilogram per square meter. Okay. And if you go to the next step, this load is given in kilogram per square meter. What you need to do again here? I'm just trying to repeat to remind you what you need to do. So first of all, the unit is kilogram per square meter. So to convert it to kilonewton, what you need to do? Multiply by 9.81 and divide by 1,000. Okay. The next step is to convert from kilogram per square meter to kilonewton per meter. So you need to multiply by the load width, which is 7 meter. So to calculate the load from roof sheeting, you need to multiply 6.1 times 9.81 over 10 over 1,000 to convert to kilonewton per square meter, and then times the load width. The load width here is 7 meter. So the final answer or the final dead load due to roof sheeting will be 0.42 kilonewton per meter. Okay. Does this make sense? Or do you have any question about this?
No, that makes sense.
Okay, so now the last step is the on weight of the rafter. So how we can get the on weight of the rafter? What do you think? Because we didn't design it, so you need to assume the cross section of the rafter. So here, the example assumed using 360 UB 56.7. So this universal beam section, and then using the table, go to the table, the design capacity table from one steel or any other table, and get the self weight of the rafter. From the tables, the on weight of the rafter or the self weight of the rafter is 56.7. So how can we use this?
So obviously, once we do all our calculations, we realize what our load would be, would then work out what the appropriate rafter is, right?
Yes, but just it's like you need to make assumption to move on and then check this at the end. So because we need to include the on weight or the self weight of the rafter, you need to have like initial section to start with, and then after calculating all the loads and moments, so you can check if this section is adequate, or you need to use a smaller section or bigger section.
Okay, but when we make our assumptions for the calculations, we base it off 360 UB 56.7.
Yeah, you can use same assumption like here. Okay. So what is the on weight of the rafter? 56.7 kilogram per meter.
Mm-hmm.
So what do you need to multiply it by the load width, or we just need to convert it from kilogram to kilonewton?
Just from kilogram to kilonewton.
Yeah, because it's already given to us as per meter, so we don't have to multiply by the load width, right? What we just need to do is convert by multiplying by 9.81 divided by 1,000. So the final answer is 0.556 kilonewton per meter. Okay. So what is the final dead load, or what is the total dead load is? The total dead load is the summation of all the components we have done. So roof sheeting, ceiling, insulation, ignore the surface, Berlin, and rafter. So it will be 0.42 plus 2.03, 0.48, 0.372, 0.556, and the final answer will be something in kilonewton per meter. What you have noticed here, all the units are consistent because you cannot sum different units. The units should be consistent. That's why we have trying to keep all the units as kilonewton per meter in all the components. Okay. Do you have any problem with the on weight? Oh, sorry, the dead load on B1? No?
No, makes sense. Thank you.
No worries. So what is the next step is? The next step is life load on B1 or the roof beam. If you go to the table of 1170.1, table 3.2, you will find a different type of roof, but this roof is under other roof because it is inaccessible roof, or like the roof has minimum life load, because is the roofs are accessible or used for storage or something like this? No, so it is only for covering. That's why the life load is minimum. So if you go to the table, the formula for life load is 1.8 divided by A plus 0.12, and the result will be in kPa or kilopascal. And the standard give us a limit of 0.25 kPa. So you have to calculate from this formula and compare to 0.25. If it is more than 0.25, okay. If less than 0.25, you have to use it as 0.25. Okay. So if we apply here, Q will be 1.8 divided by A. What is A? Can you tell me what is
That's
A?
the area of the
Yeah, this is the
tributary
area, the area covered by or supported by the beam. So what is the area supported by B3?
16, yeah, that's right.
Yeah, 16 times
Multiplied.
7 multiplied by 7, right?
Yep.
Yeah, so this will be similar to your assignment. If we apply this to your assignment, can you tell me without numbers what will be it? 16 is the beam span. And what is 7? Bay spacing. So in your calculation, Q will be 1.8 divided by beam span times base spacing, whatever the beam span is and whatever the base spacing is. Okay? Is that clear?
So far, so good.
Sorry, Nasser, can you repeat?
No, so it's all good.
All good? Okay,
Thank you, Ahmed. Yeah, I've understood that. I don't know about the rest of the students, though, but
Yeah, thank you. Okay, so 1.8 divided by 16 times 7, where is 16 is the span and 7 is the spacing. Okay, and this is the pink area or purple area here. Plus 0.12. So what is the final result is 15 or 0.15 kPa. So 15 is 0.15 is less than 20.25. So what is Q?
so we use
0.25.
0.25.
Yeah, so this also
Gotcha.
something you need to consider. You have
Yeah.
because most of the time this value will be less than 0.25. So you have to take it as Q equal to 0.25. Okay. So now we get the Q on the roof in kPa. How to calculate the life load on B1? What is kPa equivalent to? kPa is equivalent to kilonewton per
Kilonewtons
square
per-
meter. So as we discussed earlier, to convert from kilonewton square meter to kilonewton, what we need to do? Sorry, kilonewton per meter. We need to multiply by load width.
Multiply 1,000.
No, multiply by the load width. It is already with us in kilonewton per meter. So if it is kilonewton, you don't have to convert to already because it's already converted. So you have to only convert from kilogram to kilonewton. But if it is already kilonewton per square meter, you need to convert it to kilonewton per meter here. So to convert from kilonewton per square meter to kilonewton per meter, you need to multiply by the load width.
Line width,
How much is the load width here again?
7 meters.
7 meters. Okay. So the final answer is 0.17 kilonewton per meter.
Meters.
Okay. So as you can see, the load width is very important in your calculation. If you decide the load width wrongly, so all the answer will be wrong. So I will ask you again, what is the load width in your assignment? Do you have anyone have answer?
It's one bay space. Is that what you mean?
It is the bay spacing. Whatever the bay spacing is, it is the bay spacing, right?
Yeah.
Okay. So just want to confirm this with you. What is the last load we have? Wind load. Okay. So for wind load, what is the standard we are using? Just a reminder, 40, 55. This is the Australian standard wind for housing. I think you are using this. Are you familiar with using it?
Yes.
Okay. So what you need to do, you have a lot of parameters in your assignment, details. So you have wind class, wind region, shielding, and all this stuff. So using all the parameter given in your assignment details, you will go to the AS 4055, and using table 2.1, you will find two speeds: ultimate limit speed and serviceability serviceability limit state speed. Because this is a requirement, is important in the assignment as well. You have to calculate both the speeds, not only one speed. Okay. What is the next step? The next step is to calculate. The next step is to calculate
The net
the-
wind pressure.
Yeah, the next step is the wind pressure. Okay, so the wind pressure using the ultimate limit speed and the serviceability limit speed. So how many times you need to calculate?
I've done 8, so roof in, roof out, wall in, wall out for serviceability, and then again for ultimate.
Yeah, that's right. So 8. And each part of the, or each component of the 8 will weighted in the mark. So you have to calculate all of them. Because it's required clearly in the assignment to calculate the ultimate and serviceability wind pressures in and out for walls and roofs. So you have 4 for walls, 4 for roofs, in and out, ultimate in and out serviceability. Okay. So what you have to do here, ultimate limit state, Q ultimate equal to 0.5. This is the formula for wind. 0.5 times 1.2 times 34. This is the ultimate wind speed. And serviceability limit state Q 0.5, 1.2, 26 square. And the answer will be in BA. And if you want it in KBA, you need to divide it by 1,000. So if you divide by 1,000, it will be 0.69 and 0.41 KBA. And why we want to convert it to KBA? Because KBA is equivalent to kilonewton per squared meter. So kilonewton per square meter will be much easier to deal with when we are calculating the loads. Okay. So the next step is to go to the, we get the like pressures, the surface and ultimate pressure. So what the next step is to calculate using table 3 the coefficient, because we have coefficient for like inward and outward, or pressure and suction. As you know, if you have a surface of like wall or roof, you have wind pressure like doing pressure or into the roof, and also suction or out of the roof. So you have to calculate for both of them. So for example here, if we go to the table, and also you need to consider only the net pressure coefficient, because we have internal wind pressure, external wind pressure, and the net. So it is also in the assignment mentioned to calculate only for net pressure, right? So for net pressure, the coefficient are -1 and plus 63.63. Okay, this is just for this example. Okay, so what is -1 and what is plus 33? Which one is pressure? Which one is suction? If you have already gone through this before, anyone has the answer?
The negative is the suction.
Yep. So the positive sign is the pressure or the inward, and the negative sign is for suction or outward. Okay. So what we will do is, for this example, what is 0.69? It is the ultimate pressure. So ultimate pressure times 0.63 and ultimate pressure times -1. This will be ultimate inward, ultimate outward. What else we need to calculate, as you mentioned, Erin? You need to use this value again, 0.41. So here you have to add two more values, which are for surfaceability, 0.41 times plus 0.63 and 0.41 times -1. Okay, is that correct, or I missed something?
Yeah, I think that's correct.
Okay, thank you. So what is the next step is, after calculating the pressure?
You have to calculate the wind loads on members of the intermediate frame. So ultimate only
Yeah.
inward and outward.
Yeah, in assignment only ultimate. So you have only how many values you will have? 2 or 4 or 6?
4. I can't really
4.
remember. I did this a
Yeah,
while
4,
back.
4, 4. 2 for column and 2 for beam. Okay? Because you have intermediate frame, not only intermediate beam. So here, what is this here? Because you are only looking for the beam, so it will be only 2 values for ultimate. So what we have to do is to find the wind load on a beam, multiply the wind pressure in kPa times the load width in meter. Is that okay? Why we multiply it by load width again?
Because of the tributary area, like that it's supporting.
Yes, because
That's
again,
what I asked about. I wasn't sure about that because it didn't show it in the
Yeah.
video, but now I understand.
Okay, that's good. So again, what is wind pressure? Is a pressure in kilonewton per square meter. To convert it to a line load or a load on beam, you need to multiply it by load width. What is the load width from the start of this example for a B1 or B3 here? 7 meter. So what we have to do is just like multiplying these values here, 0.43, 0.69 times 7. 7 is the load width. Okay. So here 3.01, 4.83, inward and outward. Inward means positive or negative, or means inward, like inward means into the beam. Outward means out of the beam. Okay. Do you want me to explain this? I just you still can see my screen?
Yeah, I can still see your screen.
Okay, so I just share a different thing. Okay, can you see here now the whiteboard? So here we will have this, if this our beam, B1. So we have two types of wind load. What is this referred to? And what is this referred to? Just to remove this here.
And one's inward, one's outward.
Yeah.
Pressure coming in and pressure coming out.
Yeah, the top one is the inward.
Yeah.
Inward, which is, from our example, was 3.01 kilonewton per meter. The second one is the outward, which is 4.83 kilonewton per meter.
Should we have a diagram of this in our report? Because I haven't done that. I've just done the calculations.
No, you don't have to. What you have to do only maybe when you write the answer like this. This is inward and 4.83 kilonewton meter outward. I just refer to just to explain to you. I want to confirm that you have understand what is meant by inward and outward. Okay, is that okay?
Yeah, that's very.
Okay, so we return back to our example. Please stop me if you need to something to repeat or something need more clarification. Okay. So do you have any problem with the load calculation? Because that's all for the load calculation. Do you have any problem? No? I just have something to explain to you before proceeding. What you think is the common mistake here in this in this calculation for wind load?
The negative and positives, maybe?
Yeah, also the load width. So and I'll just share my screen again, my whiteboard screen again, sorry. Okay, so again, to calculate the wind loads equal to wind pressure times load width. Okay, is this okay? So for beam, it will be the wind pressure on beam times the load width of beam. So for example, our shed or our plan, if this is the beams, sorry, if this our beams, I will name this as B1. What is the load width for B1 again? If this was 7
meters.
7, yeah, 7 7.
16 by 7 if you want the
yeah, this 16 meter. Thanks, Nasser.
Yeah.
So if we take the load width, so half from top again, half from bottom. So this is the load width of B1, which is 7 meter. So for example, as we mentioned here, the load pressure was, for example, 4.3 and here was 7 meter. The common mistake is here. Some student or from previous deliveries, just want to mention to avoid, okay? From previous deliveries, taking this 7 meter by 16 meter instead of 7 meter. So what is 16 meter here? They take the beam span as load width. Is it correct?
The beam span.
Not correct. So the load width is not the beam span. Is that right?
Of course, it's different.
Yeah, okay. So I just want to explain to avoid this in the future. Because what is not in the example, the wind load on column. Is it an example? Have you done this or not yet?
No, we haven't done it. I don't think we were.
So I will explain like quickly. If this our shed, in this is the one in your assignment. Okay, what is this dimension? If we
16.
consider 16 meter, what is this dimension is? 7
can't remember what. 7
meter.
7.
Okay.
Yeah.
If we have wind load in this direction here, so the wind load will be something in this direction, right? The wind pressures. Anyone have calculated the wind pressure on wall?
Yeah, I've done it on the wall.
Yeah. So wind pressure on wall will be some values. Let's say 0.5 kPa and 0.4 kPa, whatever the value is. Okay. Can you calculate the wind load on the column? This is the intermediate frame, right? Is that
I just did it
acceptable?
the same and then used the width of the one
Yeah,
base spacing.
yeah, that's why I'm explaining, just to make sure that you all understand, because the common mistake is here as well. So here, the wind load in column. So wind load in column, can anyone mention what is the wind load on C1 or on the column, intermediate column? It will be the values of the wind pressure you got, 0.5 and negative 0.4 times the load width. What is the load width of the column?
It's one base space as well. It's the same.
Same, yeah, that's it. So similar to B1, let's say C1 will carry same load width. It is the base basing, which is 7 meter. Because what happened in previous deliveries, they take the load width of the column as the column height. The column height is wrong. Column height is not involved in this calculation. Okay, because what we are doing is just trying to convert these green arrows to the area on this red column. Okay, so what is the formula? The wind load on column equal to the wind pressure on column times the load width of the column, which is similar to beam load width. This is the trick in this example. So the load width for beam similar to the load width of the internal column or intermediate column. Okay, all good?
It's a great tip. Thank you.
No worries. So do you want to continue or because already
Continue. We're
Okay.
loving it.
Sorry,
If
can I
you-
just play that back to you just to make sure I fully understand? So when I'm talking about the
Yeah,
wind
sure.
load, I'm just talking about it on, let's say in the example, we've got rafter B1 and then column 2. So I'm not trying to work out the wind load for the entire building or anything. I'm just doing it on those two items. So rafter B1 and column 2.
Yes, that's it
Okay,
only.
cool.
So what you
Beautiful.
have in steps you have to calculate the surface wind pressure, alternate wind pressure on the roof, surface wind pressure, alternate wind pressure on the wall, and then the load on B1 will come from the wind pressure on like roof related to beam, right? Wall related to column.
Yep,
So to calculate the wind load on B1, you need to multiply the wind pressure on like you still can see my screen, right?
Yep.
Yep.
Yeah, like here. If you want to calculate the wind load on B1, you need to calculate the wind pressure on roof times the load width of the beam.
Yep,
Okay, and
Perfect.
similarly, if we go to the column, we need to calculate the wind pressure on wall times the load width of the column. Here the trick is the load width of beam equal to the load width of the column because they are both like same element or same frame. So they are repeated with similar spacing.
No, that's great. Thank you.
No worries, thank you. So that's it for the loads. The next step in the example is the load combination. Okay, so now the load combination. How we can get the load combination? How many load combination we have? 5 for beam 1. Why for B1 we have 5? Because B1 is a roof beam. So B1 has wind load and dead load and life load. Right?
Yep.
So what we need to do is just from the previous steps, we have 1.35 G. So we get the dead load from the previous calculation and put it here. Okay. What is the next combination is 1.25 G plus 1.5 Q. So again, 1.5 times the dead load plus 1.5 times the life load. Okay. And please note that all the answers are in kilonewton per meter because we are calculating load on beam. So all the loads in kilonewton per meter. Is that correct?
Yep.
Yeah, okay. So here in 3 is similar to 2, except for this psi L, which is coefficient for long term and short term deflection. So if you go to the table from 1170.0, you will find the formula for combination and also the parameters needed. Okay, so all the time 3 will be less than 2 because you have here psi is like smalling or a reduction factor. So do you expect 3 will be more than 2? No. Okay, because they are similar, just we are reducing this one, but it sometimes for other special cases can be different. But for our course, all the time, this will be greater than this. What is the most important ones in our calculation for roof beam? Number 4 and number 5. Number 4 is 1.2 G plus W ultimate plus psi C Q. Here, this one is for wind inward. So which value will take positive or negative?
The positive one.
Positive one. So this formula, number 4, all the time will give us a positive value because all the loads are positive. So again, 1.2 times 4.56, the dead load, plus W ultimate, if you go back here, this inward 3.01. So we just put 3.01 plus psi C also 0. So we have the final value is 8.48 kilonewton per meter. In number 5, what is the difference between 5 and 4? 5 is for wind inward, 5 is for wind outward. So we have 0.9 G plus W ultimate. Which W ultimate? Negative or positive?
Negative.
Negative, which was from our calculation 4.83.
3.
So 0.9 times 4.56 minus 0.483. So the final value is negative 0.73. What does it mean by negative? Upward. What means by positive here? In like downward. So what do you expect from this loop combination in your calculation?
Then we use number 4 because it's the most adverse one. Yeah.
Yeah, we have to we select 2. Why we have to select 2? Because we have positive values and negative values. So what we will select? The maximum in positive and the maximum in negative. Okay. So what we will be using? Number 4 and number 5. Number 4 is the adverse in downward, and number 5 is the adverse in upward. Is that to make sense?
Yeah, that makes sense.
Okay.
Yep.
So you have to select this two. This you mentioned before, Erin, that there is a requirement of, sorry, Joseph, that there is a question to discuss. What if we apply the critical load combination? So what are the critical load combination in this example? Number 4 and number 5. Okay.
Yeah, number 4 and 5. Okay.
Okay. So now the next step is to design the beam. How to design the beam? To design the beam is to find the maximum moment, and also I think it is required to draw the bending moment diagram and shear force diagram. Have you been able to do this? Have you done this or not yet?
Me personally, no.
I
Yeah,
have.
me too. I haven't done it yet either.
Okay. So I just will share my screen again, the other screen. So using the critical load combination, just to quickly draw it. So we have number 4, which is ED equal to 8.48 kilonewton per meter. Number 5, ED equal to negative 0.73 kilonewton per meter. So what you need to do is for example, this is the positive value. The load is downward, 8.48 kilonewton per meter. If the requirement asked to draw the bending moment and shear force diagram, anyone can help me to draw it? For the bending moment diagram, what you expect? The maximum bending moment diagram will be in the middle here.
There'll be a point in the middle.
Yes. What is the value? WL squared by 8.
It'll
So
be
it will
minus-
be 4.8 times 16
Length.
squared divided by
Yeah.
8.
By 8.
Okay. Can you help me to find the shear? As you know, we can concentrate this to be 8.48 times 16 meter, which is the whole length, right? So the shear will be two triangles like this, sorry.
Was it WL on 2 or something like that? I can't
Yes.
remember.
Yeah, that's it. So WL by 2, WL by 2, this is positive, this is negative. WL by 2, so it will be 8.48 times 16 over 2, right? So this is the shear force diagram, and this is the bending moment diagram. Is it easy?
Yeah.
Yeah. For
So
the next,
with what you've just drawn, Ahmed, do we put that in our report as like a table, or not a table, like an image, or do we put it as an appendix based, and we just refer to it? So I think that's part of what the question is.
no, why
right?
you put it as a appendix? Because it is one of the requirements. So just put it inside the text.
In the text, okay.
Because it is one of the requirement. If it is not a requirement and you want to put it as appendix, it's okay. But I think it is one of the requirement.
Yeah, it is.
Can we skip doing the reaction forces then? Because I've put the reaction forces in, but do I not need to do that?
Yeah, because it is like just straightforward and like one of the very famous cases. So you can just, if you put the two values correct, so that's it.
Okay, thank you.
No worries.
Sorry, with
So-
the diagrams, can you hand draw them and then stick them in or something? Or do you have to, like, how do you?
Yeah,
Yeah,
yeah, but
okay.
just with hand drawing, try to make it maybe use a pen instead of, because pencil, as you know, when you scan, it sometimes come very, very bare. So
Yeah, sure.
if you can make sure that will be clear, that's it. Thank you. What is the other case is? The other case is the load upward. I think for this case, maybe you don't have to draw it, but if we want to draw it, can anyone help? Or it will confuse you. I will only draw the moment, but what do you expect for a moment? Here, when the load was down.
In the middle. We'll be in the middle again.
Yeah, in the middle, but below or above the data?
Above.
Above. So the moment will be something like this. Still parabola, still the maximum in the middle, somewhere here, WL squared by 8, but it is reversed. Why it is reversed? Because the load is acting upward. So the bending will be like this. So if we want a value, the maximum value here, what to expect for the maximum value? Because this is required in your calculation. So it will be the load 0.73 times the span 16 square divided by 8. Okay, is this clear?
That's very clear. That's a good tip because we didn't do any of that in any of the examples in the learning weeks, you know what I mean?
I just do this also for because you mentioned this last week, so I was intending to do this week.
Well, I
Great
haven't
idea.
done this in my report, but I think it's because we have to do this for beam 2, which is an internal beam, so it doesn't have the wind load.
Yeah,
So I haven't done this negative one, which is what's just put me off now. I'm not
That's
sure.
what I'm saying here. That's what I said. Because we didn't come across any of this negative one. It was
Yeah.
all
I
about the
don't
positive, the
think-
bending moment, the
You want
bending
me
moment
to
below.
remove it?
I don't think we have to put it in the report, do we? Because
Yeah, no.
I've done it all and I haven't actually done that. So
Yeah.
I was like, I don't know now.
Not in
But
the
mate,
report.
that's a great lesson. That was a good something to learn that we haven't learned before. That's all.
It's
Yeah,
good to know,
because
yeah. But if I
yeah,
need to put it in the report, I need to go back to my report.
no, because you said the important thing. What is that B1 is internal, is external beam or roof beam, so it is subject to upward and downward wind load. But for B2, it is internal beam, so there is no wind.
Yeah, because all this extra stuff is only for for the internal, the floor beam.
Yes, but if we continue our example here, you will see what I have done. I think you haven't go through the example before. Is that correct?
No, we haven't. That's what I was saying. No, that's very good.
I've done it all for the positive value, not the negative. So
Yeah. Okay, so if we go here, this is the positive value of the moment. So as we mentioned, 8.48 times 16 squared over 8. So this is the value of the moment. Okay, and I just will skip this one now, and just to go for this one first. So the positive or the downward moment will be something like this. How we get this one? Again, 8.48 times 16 squared over 8. So the positive moment, as you can see, will be below the data. Okay, for the reversal action or the upward, so this time the bottom flange is under compression and no lateral strain, and the moment, how much the moment is 0.73 times 16 squared over 8, which is 23.36, and the moment will be, as you can see here, above the data. Okay, so for this case, the moment is below the data. Sorry, for this case, the moment is above the data. Okay, are you happy with that?
Yes.
Okay, so up to here, I think because it is not required in the assignment to design B1, so maybe we can stop here, and then because I need to I need to explain something in the floor beam. But have you go through the design of rafter before?
No.
Okay, so I will explain only for the positive moment, because as you mentioned, Erin, it is not required to design the negative because there is no negative. So we have only to do the positive, okay? So I will stop at the positive here. So what you need to do to design a rafter, you need to use this chart. What is this chart is? This is the design
The
capacity
universal
table
beams.
for UB section. What is UB section stand for? Universal beam. So if you look at this chart, what is in the y-axis, what is in the x-axis, and what we got. If you look at the y-axis, it is design
That's the
member
low
moment
loads.
capacity. Yeah, this is the member capacity or moments. So in y-axis we have moment. In x-axis we have effective length. And what we will get from the chart or the table, we will get a section or a cross section. As you can see, there is several numbers or several cross sections. So what we need to do, we need to get a section or a cross section. So to get into this, we need to know two things. What is these two things? The moment capacity and the length. So what we have calculated in the previous step, the moment. How much the moment is?
271.36.
So this will be on
the left-hand side, so up there.
the y-axis. So you have to draw a line, something like this. Okay, so this is what we are using from moment. What else? The effective length. What is the effective length?
The length.
it's
The length of the beam.
Unrestrained length or something.
Yeah, unrestrained length. What is unrestrained length? Unrestrained length is the length that is subject to buckling or susceptible to buckling. Okay, so if we go just maybe on top here. So when the top of beam is under compression, so this is because buckling is related to compression or tension. Compression. Member under compression is subject to buckling.
Buckles.
Yeah, that's why we are looking at the top
of the beam.
or the top flange. So the top flange is under buckling or under compression. So the unrestrained length for a roof beam is the distance between the
The
purlins.
purlin.
Okay, because the purlins are supporting the top flange. But if there is no purlin, so it will be the whole span. Okay, is that clear?
Yeah.
Okay. Anyway, for our beam here, because we have purlin, so the purlin are supporting these points. So the unsupported length is only the distance between the two purlins here. How much is the distance between the purlin? 1.78 or 1.85. These are very because the slope is very small, so it will not affect much. So the unsupported length here is 1.85. So if we go to this table or this chart, so here is the point of 1.85. Is that correct? So we will go up with a line, straight line, vertically, until we intersect with our horizontal line. Where they intersect at this point. This point is close to which chart or which curve?
The Y.
Yeah, this one. So if we consider, so it will be intersecting at this curve. So this curve is representing.
Ahmed, can I ask something? Can that distance be below the zero? The
Sorry, can you
unsupported.
say again?
Can the unsupported
length be zero?
Yeah, can it be below zero?
No,
it can't be. It has to be something, doesn't it? So it has to be above the zero.
Yeah. Otherwise, you are like putting beam.
Nothing to care because that's I think the minimum beam you can have is the 3210 or no, the 250 31.4 or something, isn't it? Or the 200.
Yeah, if the moment is very small, something like here. So what is the first beam you can get? This one.
Gotcha. Is the 150 UB14. That's the lowest beam you can have. Gotcha.
Yeah.
Okay.
But I will delete this too, just to not confuse anyone. So we have intersect here. So what is the effective length in your case? For example, Erin, because you already have done the example.
The space between the secondary beams for the flooring.
Yes, because this is the difference between the assignment and the example here. This example, we are doing a roof beam. So the roof beam is supported by or restrained by the purlin. But for a floor beam, it is supported or restrained by the secondary beam.
Columns.
And there's no slope, so you don't need to do the cosine 15.
Yeah, no cosine because it is already horizontal, so there is no slope. Okay. Not the columns, Nasser, because
okay.
I can draw it again.
Oh, so you're saying we're doing? Sorry, I was on it. So this example now is referring to the floor beams.
This example is for a roof beam.
A roof beam, gotcha. Okay. Yeah.
Okay, but in the assignment, it is required to do for a floor beam.
Okay, gotcha.
But they are same concept. What is the top flange of the floor beam is supported by the secondary beam. Okay. Because what is the difference between secondary beam and the roof beam? Sorry, the secondary beam and the purlin. The secondary beam is still supported by the rafter, but they are in same level. This is the difference. Okay. Anyway, I just try to compare.
Yes, sorry, yeah, no, I got that. Sorry, I was on mute. I didn't realize.
No worries, it's okay. So, do you have any problem with selecting the beam?
No, all good.
So you have to get into this chart using two values: the moment on the beam here in kilonewton,
effective length,
and the effective length of the beam, which is the distance between the secondary beam in your assignment. What is the?
Make sure you use the correct table, because the first time I did it, I used the wrong
Yeah.
one. I used the axial one, but this one's the moment capacity one. Make sure you check that on the side, just a hint.
Yeah, this is a good hint. Make sure that you are using the correct table because you are looking at moment because we are designing a beam. So beam is designed based on moment and effective length. When we go to the column design, you will use the axial load with the effective length or buckling length. Okay? And also, please note that for beams, you are using UB section. For columns, you are using UC section. Because in this design tables, if you go to the, because I think the one you are provided on the learning website, maybe only focused on few examples. But if you download one from the web, so sometimes you use UB for columns, sometimes you use UC for beams. So you will find capacity table for U beam axial and U beam moment. Also for UC, you will find moment and axial capacity. Okay, anyway, this is a good hint from you, Aaron, to use the correct tables and make sure you are using it correctly. Okay. What is the next step after getting the section? The next step is to check. We already checked the moment and the capacity, so we get the beam is safe. But we have another point very important, which is check of serviceability. This is also one of the important requirement. What is serviceability?
That's what it can hold safe, like more safely at a normal use or something like that.
Yeah, because as you know, we have two types of criteria when designing. The strength, which is making like the structure safe or will collapse or will be unsafe. The other is serviceability, which is the deflection and deformation check. So maybe the structure is still safe, but when you look at the roof or at the roof, up front you see it's very, very saggy or something like this, so you feel unsafe. It's something like for like normal life or under normal loads. So even it is safe and it will not collapse, but you will feel unsafe because you see it very saggy, something like this. So we need to make sure that also the beam is safe for serviceability. So in this example, this is a roof beam. So you need to calculate the load combination for serviceability. What is the load combination for serviceability from this table is?
As dead load and what's
Yeah,
that single? I don't know about that
G.
sign and live load.
Yeah, G plus F psi L Q.
Yeah, Q,
So,
which is perfect.
Yeah, you need in your calculation to calculate also this load combination for the deflection because it is one of the requirements. So G plus F psi L times Q. Okay,
Yeah.
and when we check the deflection, we will check with the span over 300.
Whether the length.
Yeah, this
so
is the
it's
limit.
be the 16 divided by 300.
Yeah. So here, what is the load combination for serviceability? As you can see, F psi L is 0 for roof.
Yeah.
So the final combination is 4.56. So the next step is to use the formula for deflection because it's also one of the confused parts. So you need to calculate the maximum deflection. What is the maximum deflection equation for beams with distributed load? Yeah, 5W to the power 4
over 384 times e to the power of 10 times the power of 5.
I think you use this formula in the
assignment. I got to admit, Ahmed, this equation here, my calculator, it never gives me the right answer. So I went from multiplying to dividing, and when I divided all those numbers, I got the right answer.
Okay, I can explain step by step to you.
I remember this instructions one letter.
Yeah, no, I agree with you as well. I came up, but I tell you, when I multiply it in my calculator, like I got the Cassia scientific calculator, and every time I use the multiplications, it never gives me the right answer. So I've done it using the divide, and it always gave me the right answer, which is
so my advice is to do it step by step. Like we can do the top part first, bottom part, and then divide it in a next step. This is what I am doing in exams or something before when I was doing exams.
Oh, okay, gotcha.
Yeah, because you cannot depend on your calculator as well. So you might miss something or might did something wrong because it is a very long formula or very long calculation. So you can do it like 5 times 4.6 times 16,000, put it on top here, then 384 times 2 point something and put it here, and then you can do the divide in a separate step. This is what I am doing to get the correct answer.
Yeah, it's also confusing that MM4, that doesn't become part of the calculation. And when you first look at this equation, that sort of tends to throw you off a bit.
Yep. So the only problem you can face here is maybe using wrong units, because if you use the wrong units, also you will find the answer very wrong. So for example, what this is E is a constant, which is 2.2 times 10 to the power 5. This is a constant. And also I is also constant. Where we get I we get it from the capacity table like here. So using the section we got for 110 559.7.
Yep. It's 216.
So 216 times 10 to the power 6. This is I. Okay?
Yeah.
So this is what we need to get from table only. So I for the selected section and E. So then 5 times 4.56 Newton. The good thing is kilonewton per meter is equivalent to Newton per millimeter. So we don't need to do anything for the load. What you need to consider or keep in mind all the time, the length, because the length most of the time given as meter. So you need to multiply it by 1,000. Right? Yeah, so then 10 to the power 4, 16,000 to the power 4 divided by 384 E and I. Okay, the final answer should be in millimeter because it is a deflection. Deflection is like displacement or like a length, so the final answer should be in millimeter. So the answer is 90.1 millimeter. What you need to do is this answer to complete because this is not only for calculating the deflection. This is not the check. The check means you check something according or related to something else, right? So this is the deflection of the beam. We need to consider or compare it to the deflection from the standard. So what is the allowable deflection from the standard? L over 300. Where we get this one again?
From the
this table. Here.
The other one.
Span over
span is over 300.
So span 16 meters over 300, 53. This means that the beam deflection is more than the allowable deflection by the standard. So what we need to do?
Get a bigger beam.
Get a bigger beam, because what happens when you get a bigger beam? You increase the inertia. When you increase the inertia, what happens to the deflection?
It decreases.
Decreases because it is reversely related, right? Just the idea what we are doing. So everything will keep almost same except for the I.
That
I
number
increase,
for the 216.
Yeah. Like for example, if you take something above, let's say this one. So what is the inertia is?
554.
554, which is almost double or close to 2.5 times the selected one here. So we selected a bigger one. Then the deflection reduced to 40.78, which is
in the parameters.
Yeah.
Which is under the 53
under the limit, 53. So the selection is.
And for the factor of safety, that comes in okay.
Yeah. So also my advice to you is you have to consider the serviceability check, and if it is unsafe, or sorry, if this case happen here similar to here, you cannot leave it like this. If you leave it like this, so the mark will be deducted. So what you need to do again?
And when we do that again, do you need to show the working out for every single time?
Yes.
Okay.
Only for
mine came out as it was good for serviceability. So does that mean that I could have done something wrong? Like, are you expecting it to need to be changed in the report, or not necessarily?
Before we was marking on like you need at least to do twice trials, 2 trials. because as you know, you cannot get the correct answer from one. Because what I can do, let's return back to the beginning of this example. What I have done here, select this one, right? Why I select this one? Is this a big section or a medium section or a small section?
I don't know. No idea.
That's medium.
Medium.
Small
So
section.
if we go to the
Yeah.
table, because we already get more than it, we reach 530, right? So it is almost
Sorry, Ahmed,
medium.
I just need to pop off. So thanks for your help tonight. See ya.
No worries. Anyway, I will upload it to the cloud. Thank you, guys.
Okay, thank you.
Yeah.
Bye. Good luck, all. See ya.
Bye.
Thank you, Joseph.
So what if you can see here, the table is from 610, and
Yep.
you have a small section and bigger section. So I can select the bigger one from start. But is this correct?
No, because it's probably cost you more money to get this one.
Yeah,
So in
because
terms of economic,
we need to design
economics,
safe and economical design.
economical, absolutely.
Because for any load, you can select the biggest one and that's it, and everyone go home. But you need to select a close
Cost you
something
twice as
close
much
to-
money.
Yeah, because more weight, more steel, so more money. That's why we are designing. So what I can suggest is, if it is very far, like let's say for this example, what is the final answer is 530, right? And for your selection, it
Yeah.
was 610. So what you can do is, if you think the selection was very far from the moment, or the deflection is very far from the allowable, you can use a smaller section instead of bigger section. So what happened here, we selected a bigger section, right? If you see here, the deflection was more than the allowable, so we select a bigger section. In your assignment, if you select a bigger selection as the first step, what you can do in the next step or the second step?
Is go to a smaller one and then show that working, yeah?
Yeah, that's it. But you don't have to go in detail, repeat everything again, but at least you can maybe check the deflection. But at least try to show that you have already done twice, or like two trials of selection.
Yeah, okay, no worries.
Okay, all good?
So sorry, Ahmed, I missed out on the first half of this Zoom. So what you've explained tonight is the chronological order for the assessment to take place, yeah?
Yeah, I gone
For the
through
report.
all the
So
examples
all the
from
steps that are
start.
required. So you went from the start, so where we should start to where we're finishing now, basically, yeah?
Yes.
Excellent. So okay. So we went through the solves. Okay. So that was week 9, I think, part 3.
Week 8, part 2.
Week 8, part 2. Okay, beautiful. Yeah.
Okay.
Yeah, too easy. But in our assessment, in the report, it starts with wind loads. It starts with reaction forces, then goes to wind loads second.
Can you say again, Nasser, please?
I said for the report for our final assessment, it starts with the reaction forces, then goes straight to wind loads. Then it goes into the design of the rafter afterwards, and then the beams and everything else.
No, there is no reaction. You mean dead load and live load? I think
Yeah,
it's
dead load, yeah,
similar
yeah,
to
yeah.
this.
Okay, so
I
similar
can confirm
format,
that the design of B1, the load on B1 will be similar to what happened in this example.
Yeah.
The
Yeah,
load,
okay, I've got that.
yeah. So if you go step by step with this example,
Okay.
so you can get all the loads
Yep.
correctly on
Follow
B1.
that. Excellent.
Because
okay.
B1 still roof beam, B1 still has under wind load, uplift and pressure,
Yep.
and same load combination. So the only thing
Yep.
that it is not required to design B1 in the assignment. This is the only difference.
Okay.
Okay, so that's it for the beams. I think we covered mostly of what happened on the beam. I just maybe don't have enough time, but I will just quickly. The next example I want to suggest to you is column design part 3. So I will close the share.
Okay.
Have you gone through columns or not yet as well?
Yeah, I've
No, I
done the
went through them.
columns.
Okay, so
I've
can you
done
see
all
my
of week
screen
9,
now?
so it shouldn't be so.
I was doing this example before, Nasser. So beam design part 2.
Okay. Oh,
Okay.
okay, yeah.
The next example I can recommend to go through is under column 9.1 column example.
Yeah.
Solved example 3. Part 3 solved
Okay.
example. Okay, so I will share
Yep.
it now. Okay, can you see it now?
Yep.
Okay, the important
Yep.
thing here I want to show you is not the, because if you follow also the design of column here, step by step, you will be able to design column C1 in your assignment, okay? But because we don't
Okay.
have time for now, so we cannot go through all the example again, maybe later, or if we can do something else. But what I want to recommend here is what is the type of floor column C3 supporting? Maybe Erin
The
can
general
answer.
storage.
Yeah, which is similar to the floor for B2 in your assignment, right?
Yep.
Yeah, so because there is not much information about the floor in the assignment. So what you can do is just to follow all the assumption for the mezzanine floor in your assignment. So because you will need to
Okay, that's a
assume
great tip.
everything. So what you will do is assume for the floor, you will assume dead load, similar thing,
Yeah.
A505 steel grating, secondary beams, main beams,
Yep.
everything same. But here, you will not go same here, because also this was a common mistake before when we refer to the column example. So they go straight away to follow same thing for beam. This not for beam, this example for column. But what you can do is just assume
Okay.
the loads from here and then continue
From the
similar
beams.
to from the beam, what we have done in the beam example. So for example,
Okay.
for the floor grating, the mass is 51.5 kilogram per meter square. What you can do?
So that's already it's already answered for us, that one, for the flooring. But it's just follow isn't it the Lysart
This one?
no.
This not like
No, I'm
that.
getting
There
ahead
is
of myself.
another
No, yeah.
company.
I was getting
First
ahead of myself.
time, that's first time fabrication, I think it's called. It's on the
Oh,
forum.
Okay.
Yeah, there is. I think John has upload or post a link to one of the brochures of this material. If you want it, I can share with you by email or something as well.
Yeah, I'd appreciate that. So I want to say once again, just follow the mezzanine floor example. And instead of using the column calculations, use both for beam and for the column, use the beam calculations, is what you're saying, Ahmed.
Yeah, for the column, it will be same. Yeah, because nothing different for column. But I mean,
Okay.
because you need to design B2. B2, for example, will be, let's say, this beam here. Okay?
Yep.
Can you see with the mouse?
Yes, I can see it.
Yeah. Okay. So, for example, if you want to calculate the dead load, so I can quickly show you something. Sorry, guys, I take longer than expected, but
it's beautiful. Trust me, we were enjoying every minute of this.
Thank you.
We didn't have enough of this. To be honest with you, in our Zoom meetings, I'll be the first to admit it. I showed up to a couple of them and they were very, very quick. But because I didn't probably do that week content, and you were there to help with it, and I was sort of like a week behind. And then
yeah, I think about maybe
this is great.
Yeah, because it didn't go through it, so it will be good to do it, and hopefully you can understand what I have said. So I am sharing now the white board. Can you see it?
Yeah.
So, for example, if we want to, sorry, so for B2, you need to assume this. You will write something like this: assume floor of, sorry, or assume mezzanine floor.
Okay.
So what you will assume for the mezzanine floor, the flooring, something similar to what is here, A550/2 steel rating. So from the table, you find the mass is 5,105 kilogram per square meter. So for example, if I want to calculate G, the dead load on B2 from this.
Mhm.
So G for the flooring will be 51.5 kilogram per square meter. This is the mass. To convert it to kilonewton per square meter, what we have to do?
Multiply by 1,000 or
Multiply by 9.81.
9.81, of course.
per
Yes, yes,
second.
yes, yes, yes.
This to
That's the
convert
inertia.
from kilogram to Newton.
Meters.
Then to convert to kilonewton, you need to divide by 1,000.
1,000. That's where I got ahead of myself.
This, you have to keep this in mind. So this
Yeah.
for any conversion from kilogram to kilonewton. Okay. Then
Yep.
this in kilonewton now, or kilogram per square meter. How do we convert it to meter? We need to multiply by the load width. What is the load width? If we go to our example again.
7 meters.
Yeah. In the example we did before, 7 meter. In this example, 6 meter. Anyway,
Yep.
it is in general the bay spacing, which is the spacing between all beams. So for the example we are doing now, because it is different example now, sir, so it is
6 meters. Yep.
So you need to multiply this by
6 meters.
meter. Okay, so G flooring for B2 will be 51.5 times 9.81 over 1,000 times 51.5. Okay, do you want me to calculate it for you, or? But I don't have a calculator at the moment, but
It's okay, we can do that.
anyway, are you happy with this conversion and this
That's
calculation?
fantastic.
Yeah,
Fantastic.
so that's it for this one, and you can continue similar to this. So what you will do is find G for flooring, G for secondary beam. I will also do the secondary beam because secondary beam may also have idea. But if you have understood the previous example, what is the secondary beam will be similar to from the previous example?
Purlins.
Yeah, so here the procedure to calculate the load for secondary beam is similar to what we have done in previous example for Berlin. Okay.
Okay.
So what you need to do is G on B2 for Berlins will be self weight of, if you can remind me, self weight of Berlins, or here will be self weight of secondary beams times
the load width
times load
times the
width.
number of
Yes, number of secondary beams.
Yeah, divided by
the span of
span
of B2. Thank you, Erin. So this is the formula or the equation you need to use to calculate the load on. Sorry, I will remove this and put secondary beam. Sorry, because they are similar procedure. So self weight of secondary beam, load width of the beam, which is here 6 meter, number of beams, span of beam. Span of B2. Okay. So for this
A secondary beam, say for example, there's B1 and there's 5 beams going horizontal. So that's what the secondary beams are. So it's B1 plus 2 on either side. Is that what we're referring to the secondary beams?
So if we return back to the table, picture.
Yeah, the picture, sorry.
Here?
Sorry.
What you mean?
Yeah, sorry. Yes, perfect. So in the middle of it, so you've got 1, 2, 3, 4, 5 beams going horizontal. That C3, say for example, I know it's a column,
yeah,
but
don't mind.
Oh, look at that.
Yeah. Look at this.
Yeah,
one,
there it is.
the sketch.
Okay.
How many secondary beam? 3.
It looks like 3. Gotcha.
Yeah, 3. So it depends on the assumption you will do. So you can mention, I
Okay.
will assume it 1.2, 1.5, whatever the distance is, because this depends on the assumption you will do. So what you can do
Okay.
is assume whatever the number of secondary beam, and if you substitute in the formula, you will get the correct result.
So,
Okay?
okay.
Because it's just a summation and the distribute again. So like what we have done in this formula, can you see the screen now? So
Yep.
we like summation all the on weight in this load width. So self weight times the number of secondary beams, this is the total loads in this load width. And then we distribute it again by divide it on the
Putting
span.
over the span of the beam.
Yeah, this is the idea, like summation of all the loads of the secondary beam and then distribute it again.
Okay.
Okay, I think this will be for G. G for on B2 will be G from flooring or the steel grating plus G from secondary beams plus G of the self weight of beam. I think that's it. No other things. So only three
Okay.
component. Also, the next step is the life load on B2. What is the life load on B2? If you can mention, Erin, because I think you.
Because
haven't
that's
done this.
you have to use the Australian standard
Yes.
general
So
storage.
That's a plant. So is it 3 or what is it? Is it 3 or for plant? Is it for plant rooms? I can't remember what they were. 5, I think.
also it is
I think they were
AS
5, weren't
1170
they? 7, yeah. So just go to that one. Yeah.
0 for life load. It depends on the usage or the use of the floor. So if it is used for general storage, okay. So let's say I will just example.
But
Sorry, go
yeah,
ahead.
it's okay. Go ahead.
Go ahead.
No, all good.
For example, the standard mentioned 4 kBA per
Square meter.
meter
A meter
of
of
height.
height.
Meter
Yeah.
square.
Yeah. Per meter, it's already per meter square, but per meter height, but height.
Of height.
So
Okay.
every meter of height will goes
Have
4
4 kilograms.
So
Yeah,
if the height, the story height
it's 7 meters.
is
Hypothetically.
3 meter, so total life load will be 4
4
kBA
times 3.
times 3, still
Which is
12
12.
kBA.
I
Yeah.
use the lowest side because it's on a pitch. So I use to the lower side. Is that correct?
Yeah. This lower side. Okay, no problem. But the idea is this 3 meter is not the load width, it's just a multiplication to know, because it is like density. So each meter has 4
kilograms. Yeah,
kBA
4
density.
kPa on it.
Yeah, so if it's 3 meters, so 12, if it's 4 meters, 16, and so on.
So I use trigonometry and stuff to get the height of that. I've shown that in my report how I've worked that out. Is that correct to show that?
Yeah, any details will be better, but I mean for minimum, so you need at least to use the load up to the lower side.
Yeah, okay.
Yeah, but I think the lower side is not given. So what you mentioned that you use trigonometry to subtract the height to get the smaller one, right? Is what you mean?
Yeah, that's what I did because it's not given. You're given the highest side of the eaves height, but not the other side.
Yeah, you need to subtract the projection of the difference and then get the smaller side.
Yeah, okay.
Okay, so now we get Q floor. What is next step is Q on B2. Q on B2 will be Q floor times load width. Is this new formula or we have used it before? Just all the time for life load. So it will be 12 kBA
12
times
6.
load width.
6 meters.
So the answer will be in kilonewton per
72.
meter. 72 kilonewton per meter. Okay. How does the next step is nothing? Wind. if I calculate wind here, what is the mark I deserve, guys? I deserve.
What? Say that again. Sorry.
If I calculate the wind load on B2 here, I will return back to the diagram. If I ask you to calculate the wind here, is there any wind here?
No,
Is
there's
this
no
there?
wind
In the
there,
center,
I don't
no.
think.
no.
Yeah, no wind here. So for this beam, if you calculate wind, you deserve to get how many marks?
100.
This is what I was asking. If I did wind here, so no wind for internal beam.
But I think it tells us that doesn't ask us to find out that, does it though?
No, it will not ask. But I mean, sometimes you students are doing the wind
Crazy
here,
things.
but yeah, but because there is no opening or no definition, no like details for any opening or any wind inside, so there is no wind on the floor beams. Okay, so for
Okay.
B2 you need only to calculate dead load and live load, and that's it.
Yeah.
Okay, and after you calculate the loads, what is the next step is, if you remember from the previous example?
Combination loads, isn't it?
Yeah, load combination, and then bending moment, and then design.
The shear design.
Yeah, go to the chart and get the required or the section.
Look at the desired cross section.
Yeah, I just want to like put some shades on this one because it is not in the design example. There is no information about the floor beam, so I want to go through this. And they are similar thing, but you cannot assume like roof sheeting and Berlin for storage roof, or sorry, storage floor, right? You cannot use same type of flow. So for roof, you can use Berlin and roof sheeting similar to example 8.2. But for the floor or the storage floor, you need to use the like steel grating and so on, and did as we have done now. And do
Just use the mezzanine flooring. Just going to use the mezzanine flooring for the steel
Yeah.
grading.
Yeah,
Okay, so
because
it's 51 point.
B2 is supporting a mezzanine floor, mezzanine floor.
Okay.
Okay, all good.
Okay. Fantastic. It's been a great help. But getting back to the equation up here, 51.5 times 9.8, and it's again you multiply it by 51.5. It's
Sorry.
so that was a mistake, wasn't it? Yeah, I was just thinking, well, what?
Sorry, thank you
Yeah,
for
because
that.
you've done it twice there, and I just couldn't figure it
Yeah,
out.
it is 6 here.
6 meters, yeah, that's what it was.
Yeah, sorry.
That's okay.
That's better to fix while we are here, so that's good.
Absolutely.
So
At least
maybe I
got that
will
understanding.
write the answer, so at least we have done something complete.
Okay, so all right.
Okay, so the value here would be 303 kilonewton per meter.
Absolutely.
Okay, all good?
Excellent. That's
Okay, thank
fantastic.
you
It's a
guys
great
for
worked out
your
example as well.
patience today.
Thank you very much. Cheers. I wish we'd done more of these throughout the week, so tell you, it would have been fantastic.
No, at least we have.
But this one is a great one. It's gone for a long time, and it's got all the information required for our final assessment, which is fantastic. You know, so
yeah, if
that's
it
been a
was
great help.
earlier, so it might be also not helpful because you will not be aware of what is the material is, and at least we will not have this discussion together. So that's why
Yeah,
it is better
excellent.
to be today.
Will it be
Absolutely.
similar? Will it be similar next week's Zoom in the last week, or?
I think this is the last week, isn't it?
Yeah, we still have one next week.
We still have one next week? Oh, beautiful. Oh, that's
Yeah,
all right. Well,
week
then
10.
we'll probably start the assessment, and then if we have any troubles, we'll get a chance to ask them again.
Yeah, and we have also all the week to ask the question on forum or on using the course email. So we are happy to help at any time. And
Thank you very much,
do you have
everyone.
any other question today?
So far, so good for me.
And,
Aaron?
Aaron, thank you for your contribution in this session.
That's all right, not a problem. Thanks for your help. It's great.
Thank you, Aaron. Thank you, Nasser, and thank you, Norazela. Norazela is not opening the mic, but anyway, thank you, Ahmed, and have a good night, guys. The recording will be uploaded to the.
Yep. Thank you.
No worries.
Thank you.
you.
Thank you,
Okay,
Ahmad. You
guys.
have a good night.
Thank you.
Thank you, Aaron.
Thank you.
All right.
Bye.